University of Cincinnati is one of the oldest higher education institutions in the United States, tracing its origins back to 1819 when it was founded as Cincinnati College and the Medical College of Ohio. The university's campus is situated in the heart of downtown Cincinnati, with about 35,000 students who populate over 100 buildings situated on more than 135 acres of land. The University of Cincinnati is like a small city within a city. The university has 3 central utility plants that deliver up to 635,000 pounds of steam per hour for heating and nearly 22,000 tons of chilled water for use in classrooms and laboratories at both the school and in its affiliated university hospital. As impressive as these facilities are, the university was faced with the problem of aging equipment and inefficient control systems. The facilities management department had to upgrade systems for providing heat and power while making the most efficient use of energy sources. They also had to reduce the cost of operating utility plants. They wanted to convert from proprietary distributed control systems, which tied them tightly to a proprietary equipment supplier, and install open control systems that the university staff could maintain on its own. They accomplished both goals with the design of new control and computing systems by Fosdick & Hilmer, an engineering and systems integration firm based in Cincinnati. They based the new operations on Wonderware's factory suite automation software products, which are now used by operations staff to monitor and control a modern network of programmable logic controllers linked to new or upgraded utilities equipment.
We started out in basically a chill water system. Then we applied it to a boiler system until we completely integrated 2 utility plants.
This installation certainly did exceed our expectations as far as training the operators, installing it without any upsets or problems, having everything tuned and under control.
The new system uses 9 in-touch workstations in the 3 major utility plants to provide open control capabilities to facility staff. Industrial SQL Server handles real-time data collection so operators can better supervise plant operations. It also provides historical data so facilities managers can perform a variety of trending tasks that were previously impossible, so they can make the most efficient use of equipment and energy resources. One of the keys to the success of the system was the ability to interconnect new control systems with a wide variety of existing instrumentation and controlled equipment.
Just the companies that we've worked with Fosdick & Hilmer and ATR and Wonderware and the PLCs, the GE PLCs, everything has gone in very well, being able to keep the plants operating without a single glitch.
The network of 11 PLCs and 9 process automation controllers uses the latest in fiber optic wiring for the high-speed Ethernet network that links all utility plants and campus facilities. One of the first benefits of not having a proprietary DCS system and the annual service contract required for it was that the university could reduce annual maintenance and support costs by 90%. The savings haven't stopped there. Thanks to the new control logic developed by Fosdick & Hilmer, one of the 2 workhorse coal boilers used to produce steam for heating was salvaged for continued use as part of the new system. With the old control system, the aging coal-fired boiler had experienced monthly shutdowns. With the new control system, this boiler is run continuously for a year without even being shut down for preventive maintenance. The cost savings that resulted from this upgrade alone have nearly paid for the cost of the new system. Another significant cost saving was the upgrade of the coal handling and control systems for the 2 legacy coal boilers used to generate steam. The new control systems that have been outfitted for the coal boilers fully automates their operations. Operators in the master control room or at a remote control panel can use the in-touch human-machine interface screens on the workstation computers to monitor and adjust the coal-fired boilers as well as the natural gas-fired boilers. The only manual labor involved now is the periodic checking of the coal boiler fires to be sure they're burning evenly with no hot spots. By being able to use the single control system to monitor all boilers, the facilities managers now have the ability to switch between gas or coal-fired boilers as they need to. This lets them use the lowest cost energy on any given day, thus reducing costs for steam production for heating classrooms.
that if we don't keep our demand power under control, it can be very, very costly to us. This system has allowed us to integrate that completely and be able to probably avoid something over $1 million a year demand charges.
By quickly achieving a 5 to 6% improvement in utility energy efficiency, the university was able to realize up to $1.5 million a year in savings just in energy costs. As happy as the university facilities staff is with the efficiencies and enhancements they've installed so far, one of the nice byproducts of the ReControl project is that it's so easy to use. In fact, very little training was required for the engineers who use InTouch and Industrial SQL Server. The InTouch screens provide high-quality graphics so that users don't have to visualize anything. It's all available to them on the workstation screens. In most cases, they don't have to leave the control room to take any control actions, and they can monitor any of their 3 utility plants from any of the control workstations. By making this city within a city one of the most efficient energy users in the nation, Wonderware's factory suite has graduated the University of Cincinnati with flying colors.